Okay, in this podcast, we're going to talk about the combined gas law. Okay, all right. The combined gas law helps us figure out the relationship between pressure, volume, and temperature of a gas. Here is the combined gas law. You see it has P1 V1 over T1 equal P2 V2 over T2. I don't like things that aren't linear, so I'm going to cross multiply. Ha 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 ha. JK. It's okay. I do this all the time, man. I screw up all the time on podcasts. Y'all are used to this. Okay, now I can cross multiply. Okay, so I cross multiply these up. Alright, and that would give me the linear form of P1 V1 T2 equal P2 V2 T1. Okay, so in that way, we have nothing in the denominator. Alright, let's do some practice problems. Alright, so in the first one, we have carbon dioxide occupies a volume of 3.5 liters. So that's going to be our volume 1 at a pressure of 125 kPa. So that's our pressure 1. And wants to know what the pressure would be. So we're looking for the second pressure if the volume was decreased to 2 liters. Alright, so I kind of forgot to tell you something a while ago. Pressure always has to be in atmospheres. Volume always has to be in liters. And temperature always has to be in Kelvin. Okay, so if we don't have those units, we have to convert. So we saw that V1 was 3.5 liters. P1 was 125 kPa. And we know that that is not atmospheres. So to get to atmospheres, you could just divide by 101.325. That'll get you atmospheres. So let's see. 125 divided by 101.325 gives us 1.23 atm. Okay, and we're looking for the second pressure. And then it told us that the second volume was 2 liters. Okay, so we already are good with our units for volume. Now we're going to plug it in our equation. Alright, so there's our equation. Alright, in this equation, we do not have any temperature values. It didn't talk about temperature at all. So we can just cross these out. Okay? And that leads us to Boyle's law, P1 V1 equal P2 V2. So now we can just plug in. So we got 1.23. V1 is 3.5. P2 is what we're trying to find. And V2 is 2. 1.23 times 3.5 is 4.305, and that's equal to P2 times 2. Divide by 2 on both sides, and that'll get P2 by itself, which is 2.15. Thanks, Tyler Cade. Alright, and that's our second pressure. Of course, you need to make sure it's sig-figged. So we have, let's see, we have 3 sig figs there, 3 sig figs there, 3 sig figs there. So that means that we already had 3 sig figs, so we're good to go. There's your answer. I stepped on my sunglasses. Sad face. They didn't break. Okay. Okay. Next one. All right. Hydrogen gas was cooled from 150, so that's our temperature 1, to 50 degrees, so that's our temperature 2. Its new volume is 75 milliliters, so that's our volume 1. Wants to know what was the original volume. Now, there's a little bit of wording here that can get confusing. See where it says original volume, new volume? That means this volume is really volume 2, right? That's what it changed to. Wants to know what it started as. So we're really looking for V1. That can be confusing if you don't watch the wording. Okay? So V1 is what we don't know. V2 is 75 milliliters. That's no good, right? We got to get 2 liters. So we're going to move 3 places this away. So it's really 0.075 liters. T1 is 150. It's in Celsius, so we're going to have to add 273. Okay, so that gives us, what was that, 323? Okay, and then our T2 is 50. Again, it's in Celsius. We're going to have to add 273. So that would be, don't let me mess up. This is 423. All right, this is 323. Okay. All right, now our equation, P1 V1 T2 equals P2 V2 T1. And we don't have what? Pressure? Okay, don't talk to me. Okay. All right, so we are left with volume and temperature. So now we're just plugging in. We don't know V1. We know T2 was 323. V2 was 0.075. And T1 was 423. Okay, so 0.075 times 423. 31.725. And that's equal to V1 times 323. So now we're going to divide by 323 on both sides. And that gives us our V1 of 0.98. 0.98. And then how about sig figs? We have 3 sig figs, 2 sig figs, 3 sig figs. So we need 2 sig figs. Oh, is that 2 sig figs? I lied to you. This one's 2 sig figs. This one's 1 sig fig. I lied to you. Okay. All right, so we only need 1 sig fig. Okay, so here's our first sig fig. Is the 8 going to make the 9 round up or stay the same? It's going to round up to what? 0.1. So 0.1 liters. Okay. All right, do we got more problems? Okay. And next problem. Gas has a pressure of 0.370 atmospheres, so that's P1, at 50 degrees, so that's T1. Wants to know what is the pressure, so that's P2, at standard temperature, that's T2. Now, what is standard temperature? 273 Kelvin, right? Okay. All right, so we got P1 equals 0.37 ATM. P2 is IDK. T1 is 50 Celsius, and if it's in Celsius, we have to add 273. So that's 323 K. And then T2 was 273, standard. All right, and then you get your little equation. Okay, and we don't have any volumes, so we could just scratch out our V's. We got P1 T2 equal P2 T1, so P1 was 0.37, T2 is 273, and P2, IDK, we don't know that one yet, and then T1 is 323. Okay, 0.37 times 273. All right, and that's equal to what we don't know times 323. We're going to divide by 323 on both sides. And we're going to get 0. Okay, and then we got to go back in sig figs. So we got 3 sig figs, 3 sig figs, and that's it, right? That's the only numbers we were given. So we got to have 3 sig figs. There's our first 3. Does the 7 make the 2 round up or stay the same? Round up to 0.313, and our unit is atmospheres, right? We found pressure. Okay. Y'all having fun yet? I'm having fun. Okay, this one is a little bit different. So we have a 2.5 liter sample, so that's going to be V1. With a temperature of 22, so that is T1. It's held at a pressure of 600 millimeters of mercury. That is P1. If the pressure is increased to 760, that's P2, and the volume decreases to 1.8, what is the final temperature? So we're looking for T2. So in this one, there's nothing to cancel out. We have all 3 variables. Okay, this is the first one you've seen like this. So let's go ahead and write out what we got. We got P1 was 600 millimeters mercury. How do you go from millimeters to atmospheres? Divide by 760. 600 divided by 760. 0.789 ATMs. All right, and then our V1 was 2.5 liters. It's already in the correct unit. T1 is 22 Celsius, so we're going to add 273. So that'd give us 295. All right, and then our P2 was 760, so we'll divide by 760 to get it to atmospheres. That's 1. And then our second volume is 1.8 liters, already in the correct unit. So we're looking for our second temperature. So we got to plug all of these things in. All right, so let's plug them all in. We got 0.789, it's P1, V1 is 2.5, and then T2, that's the one we don't know, right? Okay, and then P2 is 1, V2 is 1.8, and T1 was 295. All right, Tyler Cade, what's 1.8 times 295? 531. All right, and that's equal to, what's 0.789 times 2.5? 1.97. Thank you, Sledge. Okay, and then to get T2 by itself, we're going to divide by 1.97. Okay, and then of course we sig fig, so let's go back up. Doop, doop. Whoa. Okay. 3, 2, 3, 3, 3. So we need 2. So how do we get 269 to 2 sig figs? It'd be 270, right? And unit for temperature is Kelvin. All right, and that's our journey through combined gas law. Thanks, third period, for participating.